Hello again. So, our next pyramid is a triangular pyramid. Now, these are called tetrahedrons. A regular tetrahedron is a tetrahedron whose edges all have the same length. So, it wants us to find the volume of this tetrahedron if the side length is 6. You can think of a tetrahedron as the 3D equivalent of an equilateral triangle. All the edges have the same exact lengths. So I'm not going to mark them. They all have a length of 6. AB is 6, AD is 6, BD is 6, AC is 6, all so on and so on. So volume. Volume requires us to find the height and the area of the base. Now the area of the base is sometimes called capital B, and that's a relatively easy find. There is a formula that I've covered fairly recently and quite often in the past for the area of an equilateral triangle. BCD is certainly equilateral since all the sides are 6. The formula goes like this. You take the side length, you square it, multiply by the square root of 3, divide by 4. Now this becomes 36. 36 divided by 4 becomes 9, and we have 9 root 3 as the area of the base. Now all we need to do is find the height of the pyramid. So the height would be drawn from the apex to the center of the triangle. So somewhere about there. We'll call that point O. Now, how can we solve this problems for the height? Well, equilateral triangles have altitudes, or I mean all triangles have altitudes, but let's consider drawing the altitude. In fact, it's good to draw the altitude because that is another way to find the area of this triangle. So since it's an equilateral triangle, it would cut this side into 3 and 3, so we get 6 total. And because it's equilateral, it ends up this angle right here is 60 degrees. It's a 30, 60, 90, so the entire, let's call this M, BM would be equal to 3 times the square root of 3. And in fact, if you wanted to calculate the area the normal way, 1/2 base times height, your height you now know is 3 root 3 times the base is 6 times 1/2. 1/2 times 6 is 3. 3 times 3 is 9. Get the square root of 3 to get the base like the way we found it over here. Aside from that, we know what BM is. We want to know, well, we could either go with BO or OM, because I want to find AO. And in order to do that, I want to make a triangle. Now, I think the reasonable choice would be to go with OB, because going with OB, we have that the side length must be 6. And how can I find BO from that? Well, if we think about it, the altitude of an equilateral triangle is also the median of that triangle. And when we learned about medians, we learned about the ratios of medians. Now this is the longer length of the median. So that means that the longer length in relation to the whole length has a ratio of 2 to 3. So that means that BO is equal to 2/3 of BM. Now, if we just plug in BM, we find out that, well, that's 2/3 times 3 square root of 3. That cancels out, and we are just left with 2 times the square root of 3. Now, that's the height No, that's not the height, sorry. That is the length here, 2 root 3. Now we can make a triangle to find the actual height. So, let's draw the triangle out. Like so, where this is a right angle, this is O, connecting to B, and A for the apex. We know that BA is 6, BO is 2 times the square root of 3. Now let's try to solve our problem. So, by Pythagorean theorem, we have that AO squared plus 2 root 3 squared is equal to 6 squared. So AO squared plus, well, 2 squared is 4 times 3 gives us 12 equals 36. Subtract 12 on both sides to get that AO squared is 24, which means that AO is the square root of 24, which can be broken down as 4 times 6. The square root of 4 is 2, and we're left with square root of 6. So now all that means we can find a volume finally. The volume, again, we have a pyramid, so it's 1/3. The area of the base, which we know is 9 times the square root of 3, times the height, which is 2 square root of 6. Now, 1/3 times 9 gets you 3, times 2 gets you 6, and we have the square root of 3, and the square root of 6 is the square root of 3 times the square root of 2. Square root of 3 times square root of 3 gets us 3 times square root of 2, which ultimately gives us that the volume is 6 times 3, 18, times the square root of 2. And that is how we can find the volume of a tetrahedron. Just remember, equilateral triangles, altitude is always a good approach. An altitude of an equilateral triangle implies the medians. Medians should get you thinking of those ratios. Keep all that information in mind.